Now this was the last question in the paper. I think it's very hard, and if I were you, I would leave this question until the very end when I know that I've answered as much as I possibly can from everything else. I think it's worth 5 or 6 marks. I haven't done it. I haven't been through it purposely because I wanted to have a good go with this live, as it were, because it looks pretty tricky. Right, so first thing to do is get a diagram. It doesn't matter how accurate or inaccurate the diagram is, okay? Just give you a rough idea of what's going on. So I've plotted h, because we're given that coordinate, and I'm going to just choose a random number, a negative number for j. I've chosen -1 or -2, okay? And I've bung that in the diagram, and I've done one for 6k, and I've chosen k to be positive. Okay, that, for the sake of understanding this question, that's good enough. Alright, now let's fill in what we've been told. We've been told that this is an isosceles triangle, so let's mark in the sides of this triangle that are the same length, because it's isosceles. So I'm going to use these little marks to show that these are the same length. When I join this up, I've been told this length is root 80 in the question. Okay, j to k. And I've also been told there's a midpoint on j to k, and that the line from h to this midpoint has a gradient of 2. So if you're going to the midpoint, and it's an isosceles triangle, I've actually created two identical or congruent triangles. I've noticed that are right angled, so I might mark the right angle on. And if this is a gradient of 2 and this is a right angle, then I actually know the gradient of this slope, don't I? So it's a negative reciprocal. So turn the 2 upside down, make it negative, so this gradient must be -1/2. Now they haven't told me that in the question, but I can deduce that because it's an isosceles triangle. So I've got all the facts I could want at the moment. I think I can come up with the coordinate of the midpoint in terms of j and k, and that could be useful. So the first thing I need to do is to write down the points j and k, not h, so I'm going to get rid of that. Cross that out, please. Okay, the midpoint of j and k. So I want to know if I add the x values of the 2 and divide by 2, and then if I add the y values and divide by 2, that would give me the midpoint, won't it? So the midpoint's not so hard to find. It's going to be j plus 6 all over 2 and 15 plus k all over 2. Now the line connecting h to m has a positive gradient of 2. And of course the gradient is found by dividing the rise over the run, isn't it? So I know where it's starting from h, which is -4, 1. And I know where I'm going to, it's this midpoint I've just worked out. And I know that going up from 1 up to 15 plus k over 2, divided by going from -4 along to j plus 6 over 2 is going to give me a positive value of 2 over 1. So I'm going to write this down as a massive gradient equation. So 15 plus k over 2 take away 1, because I want a positive gradient, all over j plus 6 over 2 take away -4, which is going to be +4. You'll notice that whichever bracket you choose to start from for the y value, as long as you're consistent, you'll get the right gradient. Okay. So if I started with the 1 bracket and take away 15 plus k over 2, that's fine, as long as I'm dividing by -4, take away j plus 6 over 2. Now that fraction equals 2, so I'm going to multiply both sides by the denominator, because I hate looking at that fraction. It's too enormous. Okay, +4. So you can hopefully notice I've multiplied both sides by the same value. I'm going to multiply through that bracket, because that's not good. That's +8, don't forget the +8, 4 times by 2. I'm also going to multiply through by 2 because I don't like this fraction at the front. So that's going to give me, what, 2j, and 6 plus 8 is 14, double that, 28. And tidying up a little bit further, I can see that I've got k plus 13 equals 2j plus 28. And now if I take the 13 from both sides, I've got an equation for k. So that's my first fact. I'm going to mark it because I'm going to be referring back to that, I think. I'll be using that later on. What I need is another way to relate k and j. And do you remember when we started looking at this, we said the gradient of the line joining j to k must have a gradient of -1/2. Now I've got some coordinates and I've got a gradient, so that's enough information for me to come up with the equation of a straight line. I know that m, my gradient, is -1/2, and I know the equation of a straight line is y take away the y coordinate is equal to the gradient multiplied by x take away the x coordinate. So let's write down the two lines that I'm going to join up. J15 is going to be joined to 6, k with a gradient of -1/2. So here we go. Y take away, now which coordinate should I use? I can use this one. Y take away 15 is equal to -1/2 x take away j. Now I could have used the other coordinate, it doesn't matter, okay? And now just tidying this up, I'm going to multiply through by 2 to get rid of the fraction. So 2y minus 30 equals minus x plus j. Don't forget in multiplying out of brackets with negative, it must become plus. Now tidy up a little bit more, and I'm going to get, what, 2y... Am I not going to tidy that up? Yeah, I think I should. Oh, I see. I'm going to put the value of y. The value of y is k, the other coordinate, is 2k minus 30 equals minus 6 plus j, and therefore 2k is equal to 24 plus j. So do you see I've now got two equations that relate the value of j and k, and that's a simultaneous equation, isn't it? So if I write down the value of 2k, 2k is equal to 24 plus j, that's my second equation. If I double my first equation, I can also get an expression for 2k. That must be equal to 4j plus 30. So now if I tidy this up, I can get a value for j. So 3j must equal minus 6, so therefore j equals minus 2. And if I stick that value back in, or substitute back into either equation 1 or equation 2, I'll use this one. 24 take away 2 is equal to 22, which equals 2k, so k must equal 11. And there's my answer. Now, I accept there are millions of ways of doing this, but that's what occurred to me when I first looked at the question, and I didn't practice it for this video, I just got stuck into it. And it is very, very hard, so you really don't want to be messing around with this question unless you've finished everything else that you can possibly do. So I'm going to look at the mark scheme. I would pause this, have a good read, but it doesn't look from the beginning that many people had a go at this question. Yeah, -5, a -1/2 gradient, that was a good one too, I've spotted. And I'd imagine that the mark scheme was very long, and I do not pretend this is the only way of doing this. There are many ways of doing this, so if you did it a different way and got the right answer, well done. Okay, but they've done it quite a different way from I did.